Well, good morning, everybody. Welcome to Xamarin University. Thank you so much for joining us for this guest lecture with Greg Lutz. Greg is a product manager at Grape City, where he manages the Xuni product, which is a library of grids and controls and calendars and gauges for Xamarin. So this is pretty awesome. We're looking forward to hearing from Greg about adaptive UI design. So how are you doing this morning, Greg?
Hey, very good. Thanks, Mark.
Awesome. And I understand you're in Pennsylvania. Is that right?
Yes, so the Grape City U.S. headquarters is right here in Pittsburgh, Pennsylvania.
Awesome. What's the weather like right there today?
I believe it's pretty warm and overcast, and it'll probably rain.
Okay. All right. Well, sweet. What do you have for us?
All right. So today we have a webinar, or I'm sorry, a lecture that I titled "Build Adaptive UIs with Xamarin.Forms." The reason why I put this lecture together is because I really felt like there was a lack of information on developing with Xamarin.Forms for tablets. There's a lot of good information out there on how to create great mobile apps with Xamarin.Forms that run on all devices, but I think that one area that was lacking is the adaptive conversation and optimizing apps for a range of device sizes. For instance, while it requires no additional work for you to run your app on phones and tablets, you may not be taking advantage of the different screen sizes, or your app may not look as good because it could be rendered off screen or stretched in wrong directions on different resolutions. But I think you'll realize after this lecture why that conversation is lacking. It's not really a fault of Xamarin or their documentation, but you'll see just how easy and straightforward and almost self-explanatory everything is when you're working with Xamarin.Forms and XAML to create adaptive apps. Since Xamarin.Forms is heavily based on XAML, a lot of the techniques that I've used over the years with WPF, WinRT, and UWP, I've been able to apply those same techniques here. So I put together a collection of tips and techniques that tackle a variety of these different adaptive scenarios. And in addition to these tips, you'll also take away some XAML best practices. But before I get into all of that, I just want to cover my bases and explain exactly what I'm talking about when I say an adaptive app and why it's important. And then we'll fly through some tips and techniques available to you today, which include these XAML best practices. So what is an adaptive UI? An adaptive UI is a user interface that adapts its layout to the needs of the user. Now, the needs of the user can be thought of several different things, like the user's role or experience. But in our case, when I talk about an adaptive UI, I'm referring to the user interface. And it's specifically a single-coded user interface that changes somewhat depending on the device size. And that's really what the focus of this lecture is. For instance, when an app is run on a smaller device, the UI could reduce its complexity, allowing the app to be used, while maintaining as much of the same experience as possible. And you've probably heard of responsive apps on the web. Adaptive is basically the same thing. I think it's just a word more commonly used by Microsoft to define their mobile platform. So I've been using it to define a responsive Xamarin.Forms app as well. So with Xamarin.Forms apps, we can now develop once for all devices using a unified C# codebase, not only sharing UI across platforms like iOS and Android, which I'm sure you're very familiar with, but also devices like tablets and phones. This means that our UI needs to be adaptive in order to maximize the sharing and reduce the repetitive code and deliver the best user experience on all devices. I think one goal you might consider, or maybe it's a side effect, however you want to look at it, of an adaptive UI is to build as close to a single UI as possible that's common for all devices. Think of this like the development goal. Of course, you also have to meet the needs of and expectations of the users, of course. But this straightforward alternative is to create a completely separate UI for each part of your app for different devices like this. If the user's running on a phone, launch the phone version of the app. If they're running it on a tablet, launch the tablet version of the app. Or if, in the case of UWP, they could be on the desktop, launch the desktop version of the app. This is sort of the extreme alternative to our goal, which is to build as close to a single UI as possible. In some cases, the straightforward alternative might be what you're looking for. But ideally, you can have it so that only some parts of your app are more extreme like this, and other parts can be shared. Nobody wants to write code more than once. And with Xamarin.Forms, we're already writing ones for Android and iOS, so we should strive to continue one code base for phones and tablets and anything else. So in order to achieve this goal, there are several techniques that allow us to minimize the amount of duplicated code and allow us to have a single UI for all platforms and device sizes. And that's really what I'm going to be focusing on for the rest of this lecture as I go through some of these adaptive techniques. I'll introduce them one by one, and then we'll recap them at the end. Okay? So let's start with some basic techniques. To illustrate some of these basic techniques, I'm actually going to use a real-world app that I wrote called Chart Builder. Now, this is a Xamarin.Forms app that's actually in the App Store that you can go download. And what it does is it allows you to build a chart by entering some data, choosing a chart type. You can customize the data, give it a title. And this app, of course, is all using the Xuni controls. But as you can tell by looking at some of these screens, this app was clearly written for a phone. But of course, I didn't restrict that. I wanted the user to also be able to create it, to use the app on a tablet. But as you can see here on some of these pages, the UI is very stretched. It looks great on a phone, but on a tablet, it's very stretched. And it really was intended. And as you'll see here, I'm going to jump over to Xamarin Studio. Here's one of those tab pages right here. And the reason why this UI stretches and fills the available space is because I'm using grids as well as some stack layouts throughout the app. Now, XAML is a beautiful application layout language. When Microsoft wrote it, they took the best from HTML and combined it with new ideas focused on building application UIs really to make them adaptive. And there are two key layout controls, the grid and the stack panel. The grid and the stack panel are the most basic ones, and with them you can do so much. With a grid, you specifically position all of its children, you set which row they go in and how many columns they span, and then based on the size you set for each row or column, the children will fill this space. And that means we don't normally set the height and width explicitly on all the children. And when I speak about creating a UI that uses good XAML techniques or best practices, this is the most basic one, the most basic tip. Because we're dealing with apps that need to render on a variety of different devices, so we will let the primitive layout controls do a lot of this automatic layout for us. And what I like about using the grid and the stack layout, and of course the stack layout just stacks items horizontally or vertically, and what I like about this approach is that it's an error-proof as far as content getting cut off if you were to use absolute sizing. If you were to use explicit sizing or absolute positioning, the content will probably get cut off. For example, if you make a text box and you set the width to 500 dips, and the device only supports 400, the right edge of the text box will not be visible. You might have a button over there, something else that the user needs to interact with. And what's also nice is that when we rotate the device, these controls will automatically stretch and fill the space. Another tip that I'm using in my Chart Builder app is I'm using a scroll viewer for overflow. So as you can see here, outside of my grid, I have a scroll view. And using a scroll view is really my second tip of this lecture, and it really is a safety net for content that may spill out of view. For example, in Chart Builder, I'm creating this vertical form, and tomorrow my users may request that I add a new row or 5 more rows, and I won't always be able to rely on these forms fitting nicely if I just use grids and stack layouts. But if I throw these inside of a scroll viewer as the parent element, all of this content will automatically overflow if the device becomes too small. So typically, if you're using a list view or a table view, you get this scrolling already. And this is because these controls have a scroll view inside them. But I think using scroll view separately gets overlooked by developers because it's not even listed as a type of control or view in the documentation. Yet, it's very useful in many situations. So by using these primitive controls, grid and stack layouts, with a grid, you can guarantee that your content is at least viewable on all size devices. So those are my 3 basic XAML best practices for laying out your UI. But probably the next tip, and probably the most important one for creating adaptive apps, is the device idiom enumeration. So basically, the scenario here is now you want to offer a different experience on different devices. You may have heard of the Xamarin.Forms.device class, and this gives you information that helps you customize layouts on a per platform basis. So it gives you information about whether the app is being run on Windows or iOS or Android, and you've probably seen this being used in many samples. The most common usage, for example, is to add that extra padding to the top of pages only in iOS to avoid the status bar being overlapped with your content. In this class, though, there's also the idiom enumeration, which tells information about the type of device, such as a phone, a tablet, or in the case of UWP, a desktop app. And this is what the code looks like. And this is typically what your code would look like if you were going to provide conditional code in your app. For Chart Builder, I thought about how I could improve the UI for a tablet interface using this code. And as a reference, I decided to look at some of the default apps provided on my device. So on my Android device, I was looking at the Settings app, and I was comparing it on a phone versus on a tablet. As you can see on a phone, the Settings app displays the content in one column, and there's minimal padding on the left and the right. But when I run the same app on a tablet, I can see that it gets grouped into two columns, and there's way more padding on the left and the right. So while this isn't necessarily the only way to create an adaptive UI, this is what I decided to tackle for my chart builder. And this, I considered maybe doing this on the home page. So what I could do here in this case, if you briefly saw the home page when I launched it, there's basically two lists here. One that is a menu of the actions you can take, and the other one is a list of recently saved charts. And if I wanted to, I could organize it so that it displays horizontally on a tablet and vertically on a phone. And of course, the saved charts list over here on the right can grow as the user creates more charts. So it's more readable this way. How would I do that if I were to do that? I would basically write code that looks like this. If the Xamarin.Forms.device idiom is phone, I will set my stack layout orientation to a vertical. So we're assuming here that I have a stack layout named main layout on my home page. Or otherwise, if it's a tablet, I'll set it to horizontal. Now this is just the key core code that you would use to switch the layouts. Of course, there's going to be a lot of other little things like padding and vertical alignment options, so it displays exactly how you may want it to be. Another page of my app that needs some adaptive love are the editing tabs that contain mostly input forms. And again, considering the phone version, I'm considering the phone version here to be good, but the tablet version is the one that appears unprofessional. Now, I could create multiple columns like I could on the home page, but again, I'll refer to the Android settings app for reference. And here's what that page looks like for an input form. What they do is they basically just apply more left and right padding. They haven't grouped it into multiple columns here. So for my simple example here, I like this approach. Let's just do that. Let's just apply some padding on the left and the right. So this is essentially what it looks like now, and this is what it will look like after. Pretty simple, right? But next I'm going to show you the various ways that we can apply this in code using the device idiom. We're going to do it using code. I'm also going to show you how to do it in XAML, and then I'm also going to show you how to do it with a global style. So the first approach to applying this conditional padding is to do a slide. Now here's the real working XAML. In the XAML here, I've defined a grid named parent grid. And in the code behind, let me jump over to that. Anywhere in my constructor here, I have a lot of code, so I'm going to scroll down to where I've put it. Anywhere in my page constructor, I'm going to write this code. If we're on a phone, we're going to set the padding to a universal, or a thickness of 10 all around. Otherwise, if it's on a tablet, we're going to apply this unique padding of 100 on the left, 10 on the top, 100 on the right, and then 10 on the bottom. Now, that's really all there is to it. Now, but if you've worked with XAML before, coming into Xamarin.Forms, you'll probably seek, one of the questions you'll probably seek out is how can we set the same code logic in XAML? And there actually is a way to do this. So on another page here, what I've done is I've gone ahead and created the same scenario, but now I've completely defined it in XAML with no required code behind. To set a property in XAML, you simply open the tags of that property, and then you create an element of the expected value type. In this case, it's an on idiom. The type arguments property here is required. It's probably the trickiest part, especially if you're setting some specialized property type. The easiest way to determine this value is to jump back over your code behind and then just check and see what the value type is of the property that you're setting. So here we can tell that the value type is a thickness, as you can see in the IntelliSense. So in my XAML page, I want to set the type arguments to thickness. And then there's two properties here. We can set tablet and phone, and we're simply just setting it to the same exact values that we set in code. But now hold on. If you're setting this in XAML, this is a clean and more sophisticated way to do it, but there's actually an even better way to do it, and that is with using a style. Now the benefit of using a style is that I'm probably going to want to apply this same padding to multiple grids throughout my application, for instance on almost every page. So let me talk a little bit about styles. Styles are a feature of XAML that allow you to encapsulate property settings in one location and reuse them throughout your app. You can create implicit styles that apply to all elements of one type, and you can also create explicit styles. The explicit styles have a key, and you have to specify which elements get that style in your app. Now, I'm not really going to go any deeper into explaining how styles work. If you get lost in what I'm showing you, you can easily just check it out in the documentation. There's a good section in the Xamarin.Forms documentation on styles. And they have a much clearer explanation for beginners. And styles are not exclusively for adaptive apps either. It's a basic feature of XAML that I'm exploring as a great way to apply a conditional style across my app for tablets and phones. Anyway, in my app's case, I'm interested in an explicit style because the style I want to create will only apply to some grids in my app, not all the grids, because I use nested grids and I use grids on some other pages. If I were to create an implicit style for all grids, my app would probably look very bad. So the way I'm going to do this is I'm actually going to go ahead and open up my app.xaml file. Normally, when you create a style, you can create it within a page. I believe it would be like this. You would do content page, .resources, and you would throw your styles in here. The problem here is that these styles are only going to apply on this page, and that's no good for what I want, because I want a global style that will work on all my pages. So the place where you have to put global styles is in your app.xaml file. So I really think declaring them at the global level is good. The app.xaml is a construct that enables you to declare these global styles, strings, and resources. And note that when you create your Xamarin.Forms app, if you want this app.xaml file, you should create a blank XAML app and not just a blank app portable or shared. I believe it's a newer template in Xamarin Studio and Visual Studio that includes the app.xaml file. For me, actually, I didn't have it and I had to go create it. I just did a web search on how to add the app.xaml file, and I found a blog post out there that showed me how to create this. But either way, again, that's something you need to, if you're interested in, go ahead and do a search and look for that. But anyway, your application file essentially has the resources tag, just like on the page. And in here, you're going to throw in a resource dictionary, and within this, you can throw in all of your different styles. So here, what I've done is I've created two styles. One that's called phone grid style, and one that's called tablet grid style. The target type for these is grid. And because I gave it a key, this now makes it an explicit style, and it will only apply to grids that I explicitly assign this key. And here I'm just setting the padding property to these values that we already saw in my previous examples. So now, to apply this, I'm going to open up another page. Since I have 4 different pages that all basically show the same thing, I'm showing a different example on each one of them. On this other page, the series page of the chart, here I'm setting the style. And basically, the style is a property on all controls. So to set it in XAML, we simply open up the style tag. And again, we're the type of the style. We're going to use the on idiom to set a different value for each device type. And here we're using the static resource key to identify this as a static resource either from our page resources or from the app.xaml resources. So these are the key, the tablet grid style and the phone grid style. These are the keys that I just defined over here in my style. So now I can go ahead and I can run this app on my tablet, and I can see the better padding used on each of these pages. So this was the first page that I opened up that I set the padding here in code behind. On the, was this the second one? No, the axis page was the second one. The second one here, I set the padding in XAML. And on the series one, I set it by using a style. And then I believe I also went ahead on the data page and the legend page, I went ahead and just used the same style as well. Now I could go back and I could change the other two, the first two that I did, to use the style. So now, let's say the user has, or maybe you're tweaking the app and you say, oh, this padding's a little too big now. I want to change it from 100 to 80 or 100 to 150. All I have to do is change it right here, and it'll apply to all my pages. So anyway, that is basically the styles. And that also is basically 3 different ways that we can use the device idiom to provide different UI for phones versus tablets. And if I were to run this, let me just run that also on a phone so you can see. That the 100 padding does not apply anywhere on the phone. So as you can see here, the padding is basically that 10, 10, 10 that I've set for the phone. Okay. Now, making your app adaptive isn't all about device size and type. It can also be about device orientation. The code examples I've shown so far do not take the orientation of the device into account. So I thought this lecture would be incomplete without at least some mention of handling the device orientation. Now, currently, there's no special namespace or class that gives you this information in Xamarin.Forms. However, by doing a web search, I found that there are some samples out there provided by Xamarin and some other tech enthusiasts that do show how to use what they call a dependency service to basically feed the device orientation from the Xamarin.Android and Xamarin.iOS projects up to the Xamarin.Forms level so you can get this information. But what I found that the easiest solution is just to compare the app's width to the app's height. Now, most, if not all, devices are rectangular, so this provides all the information you need. Now, of course, this doesn't tell you if the device is upside down, like perhaps a dependency service might, but I think in most case scenarios, all you really want is that, all you want to know is that, is it landscape or is it portrait? So why might you want this? Well, consider the home page of my chart builder app. Perhaps I would like the orientation of the stack layout to be horizontal when the app is landscape, regardless of whether it's a phone or a tablet, and then have it be portrait, or have it be vertical for portrait, regardless of the device size. And the way we do this is we basically listen to the page's size changed event on any page, and then you can get the app.current main page delivers the main page of your app, and you can get the width, you can get the height, you can compare it. If the width is greater, it's obviously landscape. Otherwise, it's portrait. So knowing how to handle this is useful, and it can provide different results from just relying on the other than just relying on the Xamarin.Forms device alone. So using the device idiom alongside these XAML best practices and detecting device orientation are among the basic techniques for creating adaptive Xamarin.Forms apps. But lastly in this lecture, I also want to cover some of these specialized features of Xamarin.Forms that lend themselves very well to adaptive apps. These things are content views, and the master detail page template. And I'm also going to be leaving Chart Builder, and I've created some additional samples to coincide with these features. First thing I want to talk about is content views. Content views are kind of like user controls, if you're familiar with any other Windows development. And what they do is they allow you to create reusable parts of your UI. So here's a scenario that shows the usefulness of content views. Imagine an app that you've created with 3 areas of content. On a tablet, perhaps you want to show all of them on one page because you have the space to do so. On a phone, you may prefer to show each of these areas on a separate tab. So let me show you how this is done in Xamarin Studio. I'm going to go ahead and open up a sample I've created called Content Views. So the way you implement this is by first creating each part of your UI as a content view. So if you're working with Xamarin Studio, I believe this is now a template. Yes, so if you're working in Xamarin Studio and you go to add a new item to your portable project, you'll see here there's a content view template type. So you would simply add one of these. Last time I was using Visual Studio, I didn't see this template. Perhaps it's there in a more recent update. Anyway, if you don't see a template, all you have to do is just create a XAML page, and then you can rename the tags. So if I were to create a XAML page, it would say content page. All I then do is rename the content page to content view. You would change it here on the XAML, and you would also then change it on the code behind. You would change this right here to be content view. So essentially, I'm defining each of my UI parts here. All I've done for this is I've just added a label that says the content view, and I've also set the background of this content view. But in a real-world app, obviously, this would have a lot more content. So here I've created 3 different content views that represent the different parts of my app. All right, and then let's first look at the single page implementation, because obviously this is the most straightforward. If you're new to XAML, you may not have seen how easy it is to reuse other XAML elements you've created by simply adding the XML namespace to the top of your XAML page. So what this is doing right here, this is giving me an XML namespace that's pointing to the views namespace of my project, content views. So back here, my content view has the namespace of this. So here I'm creating this namespace called views that points to that. Therefore, I can then access these content views directly in my XAML. And I can reuse them as many times as I want on as many different pages as I want. You'll notice here I put these 3 views into a grid. But what's interesting here is I didn't define any of the grid rows or grid columns. And this is a neat little feature of Xamarin.Form XAML, where it automatically creates the number of rows and columns based upon the properties set on the children. So when we assign a child to grid row 1, a row will be created. So it just helps clean up some of the XAML. But if you wanted to specifically set widths and heights to the rows and columns, you would still need to define them the old-fashioned way. So this page is pretty easy. Next, let's look at the tabbed page. This is going to be the one that will be displayed for phones. When you create a tabbed page, again, this is another template that I don't think is available. You just have to create a content page and then rename it to tabbed page. But the way a tab page works is that it expects each child within the tag to be a navigation page. So here I've declared 3 navigation pages. And within the navigation page, I'm able to pass in my content view as an argument. And you'll notice I've wrapped each of them in a content page as well. I think it's because I'm essentially creating a new navigation page from existing content. And that can only be from another page, not a content view. It looks a little redundant, but it works and eliminates the need to create so many files. If you look at other examples, they might actually create an additional page file for each one of these tabs. But I think it's just a little messy, at least from the project perspective. Now we just need to add one little directional piece of code in this app that directs the tablet apps to the single page and the phone apps to the tabbed page. And here I'm going to do that right in my app.cs file. This is when the application is first run, it hits this, and this is where you set the main page of your application. So here is where I'm going to use my device idiom. Check, and we're going to say, hey, if it's a phone, we're going to set the main page to the tab page. Otherwise, we're going to set it to a single page. I have here my simulator for the phone. So when I run this app on my phone, you can see 3 tabs. And now I'm going to run it on a tablet. The important part to realize here is that we're reusing these content views without having to duplicate any of the critical UI or code behind that may live on each of these views. We're creating separate pages for each version. However, these pages are just empty frames, basically. The single page, or my single page, my tab page, these are basically just empty frames. By modularizing the UI, we can easily change it in the future. So if there's changes to the content view 2, which is the red one, we only have to do it in one place, and it'll still work nicely for both tablets and phones. And of course, within each of these content views, you can apply the same little adaptive techniques that I showed earlier with using device idiom to switch the padding, maybe switch the orientation of the stack layout or whatever. You can even rearrange items within a grid. You can do all those, you only want to do those little tiny tweaks within each of these. Anything major you'd probably want to just direct to a different page with reusable content views. Now, while most of the standard pages and views in Xamarin.Forms look and behave the exact same on both phone and tablet, there is one type of page that offers a unique adaptive view per device, and that is the master detail page. Now, the master detail page is a single page template, and it manages 2 pages or 2 areas of content: a master pane that typically will display a list of navigation items, and a detail page of content. Now, when you create a master detail page, it's recommended that the master page is a content page, and the details can be anything like content, tabbed, or navigation. But what you may not realize is that you can actually put any content in these pages, especially the master. You aren't restricted to just making it a list view. So let's take a look at a similar example as the one before in Xamarin Studio. So the way this works is you're going to add a master detail page to your app. And again, this is probably a template that's missing. You just have to create a content XAML page and rename the tags and the class and the code behind. Then the 2 key properties to set are the master property and the detail property. Each of these properties expects a page. In my sample here, I've actually gone ahead and defined my master page in XAML. And then in the code behind, you typically programmatically set the detail page as needed. Because, for instance, in your master, if you're displaying a list view, you'll typically determine the detail that needs to be loaded based upon which one the user clicks. So you'll see here that in my constructor, I am setting the detail to one of the pages, just as the initial one. And then as on the item selected event of the list view, we're navigating to whatever page is selected, whatever page is selected from the list. Oh, and of course in my list view, I've created this class that basically contains the type of page that gets loaded for each item. So essentially creating a navigation. But again, the 2 key properties to set are the detail, which you typically set in code, but you'll see examples that also define it in XAML. It's not out of the question. And then the master property, which here I'm setting in XAML just so that it creates a much cleaner app. My entire master layout is completely right here. And a few other little properties you can set, like the icon, which will give you a nice little hamburger button. So this is essentially what I'm creating. Let me go ahead and run it here. We'll run it on the iPad. And what makes this really, why I'm including this with the adaptive talk is that the master detail page provides a different experience on phones and tablets, and you actually have control over this. So one of the key properties that you can set here is this property called the master behavior. And this allows you to sort of configure how you want the master page to behave, as the property suggests. So what I have done here is I've set it to split on landscape. And what that means is that when the device is in landscape, the master pane is as a split view, essentially. So it's always displayed there on the left. If I were to go ahead and rotate it, the master pane disappears. And it essentially becomes, whoops. I probably didn't test that. I probably tested that on a phone. Yeah, it's impossible to give a presentation without a bug. Anyway, so essentially, the setting that I've set for this is to do split on landscape. That means if it's portrait, even on a tablet, it'll display like you're seeing it now on this phone, where the master page essentially slides in and out like a hamburger menu list. So this is, I would say this is pretty adaptive because it's giving a very different experience on a tablet versus on a phone. If you set this to default, which I believe is the default value, then you get essentially split on landscape for tablets, and for phones you always get this. Well, let's see what happens if I rotate the phone to landscape. Okay, it remains like this. Okay. But now to show that you can really make the contents of each master detail anything you want, I went ahead and created another sample that combines the content views with the content view sample that I just created with the master detail page. It uses the master detail page to create obviously the master panel. But here I'm also using the tabbed page technique for phones and the single page technique for tablets to display some content views that are reusable and reorganized in different layouts. So let's go ahead and run this on my phone here. So page 1, page 2, pretty normal. But as I go down to page 3, you'll notice page 3 is now the tab view. If I run this on an iPad, page 1, page 2, page 3 is not tabs, it's displayed using just a grid like we saw before. And of course, I'm using the device idiom enumeration here somewhere. Let's minimize this. So whenever we're loading the page, we're basically checking, hey, if we're loading page 1, we're going to load page 1. If the user clicks page 2, we're loading page 2. If the user clicks page 3, if they're on a phone, we load the tabbed one. If they're on, or otherwise, if they're on a phone, so if they're on desktop or tablet, we load the single page view. So this is just a neat little example that proves that you can combine all these features into one. Before I wrap up, I wanted to at least mention the relative layout control. It's a new alternative to the grid and stack layout for laying controls on your page. The way it works is you can just dump any number of controls into the relative layout element, and then each one's position is determined by the width constraint, the height constraint, the x constraint, and the y constraint. Now, while this control certainly has its scenarios where it makes sense to use, and I think why people who like it tend to like it because it reduces the amount of markup that a grid may require. So for instance, if you want an element to be displayed sort of in the middle of a page, you may have to create some dead columns and rows or whatever. People don't like to do that. So in this case, you could essentially just set the constraints to have the item display in the middle of a page. Personally, I don't find this easier to use or read than a grid or stack layout scenario. Just looking at all this on my slide here, it makes my head hurt. But some people like it. I just wanted to make sure I include it because it definitely plays a role in certain scenarios when you're creating adaptive layouts. So, to recap all these tips and techniques I've covered today, number one, it's important to use best practices with basic layout controls like grids and stack layouts. You want to avoid using absolute positioning and explicit sizes on objects. Instead, you want to make sure that children fill the available space. And when you do this, you won't have to worry about all the different resolutions out there, especially for Android, where the phones can come in so many different types of resolutions. The second tip: use scroll viewers as an overflow backup. If you aren't already using a list view that has scrolling, scroll view basically instantly gives you an adaptive flowable content. The third and most important one, the device idiom enum, is the most helpful for writing device-specific code. And it's useful in many different ways, as I showed. You can do it in code behind, which is probably the most straightforward. But if you're into MVVM and doing XAML, you can of course set it in XAML. And if you want to be really efficient, you can create styles that apply them across your entire application. You can handle device orientation changes in code by comparing the page width to the page height in the size changed event. Another basic little tip to know. And you can use content views when you want rearrangeable and reusable parts of your app. It results in cleaner code with minimal duplication. And finally, I briefly covered the master detail page template, which does provide a nice adaptive navigation layout for you, and you don't really have to do much work to obtain it. So that pretty much wraps up this lecture. I've listed here, these are some good links that I've used to help put together this content. Of course, the Xamarin blog, the Xamarin documentation. If you're curious about the app.xaml file and you want to know how to create that, you could just do a quick web search and you'll probably find this link here that shows you how to create one from scratch. So if you have an existing app, that's probably what you'll need to do. So we can pause to answer any questions, but if we don't have any questions, you can reach me at Greg Lutz at Grape City. You can follow me and my product at GoXuni or www.gozuni.com.
Awesome, Greg. That was excellent.
Thanks, Mark.
So if anyone has any questions, we can open up the mics, or you can put them into the questions window. Greg, I think I've answered most of them up to this point, but you may just want to check really quickly. And before everyone starts to take off, I want to remind you that we actually have a couple of new courses that hit our schedule today. One of them is XAM 135, which is our first layout course. And so it goes into detail on grid and stack layout and layout options and some of the things that Greg even touched on here. So make sure to check that out. And also, we've got another guest lecture coming up next month on cross-platform 3D. So if you're interested in building 3D apps on your mobile devices, make sure to check that out in September with Michaela Hutchison. So Greg, there are a couple of questions. How would you create a dynamic grid layout that grows and shrinks columns in the page as the page size changes?
Okay, so I guess the nice thing about when you create a grid in XAML is that you can define multiple rows and multiple columns, and for each column, let's see if I have an example here. Single page, where's that one? So in my example here, unfortunately, I didn't actually define the columns or anything. Let's say I wanted to define some columns in my grid. Whoops. I would go about it like this. Say I need two columns. We're going to do column 1, column 2. And for each column, you want to set the width property. By default, the width is this, which is just an asterisk. And what this does is this says it takes up the remaining space. That's what the asterisk means. So if I have one column, that means it'll take up all of the space. If I have two columns, they will share the space 50-50. So in essence, we're creating these scalable columns. And if you want one column to change the width, you could simply change this property, either dynamically, or you could set, one of the little tricks here, I don't know if you're familiar with, is that if you set the width equal to 2 asterisks, this means this will take up 2 times the available space, and this one will just take up 1 times the available space, essentially resulting in this column being twice as large as this column. So in essence, playing with the width properties is the solution to what you're probably asking. And then with rows, you do grid.rows, row definitions, and for the rows you set the height instead of width.
So he added to that question, he said, what I meant was, how do you add or remove the total number of columns as the page size changes?
Okay,
I think
so I guess you would just want to do that in code.
Yeah, I think he means dynamically in code.
Yeah, so if you want to manipulate your grid dynamically, what you'll do is give it a name. We'll just name this my grid. And now you can just change it in code behind. One of the tricks I think people may not realize is that how do you change, the children of a grid in code? Like, how do you change their position within the grid in code behind? So let's say here, dynamically we want to do, all right. Nice that text here. Sweet. Watch this. There's no completion in Xamarin Studio, but I will just copy this. So within my size changed, I can get the width and the height, whatever logic I want to do there. I don't, know exactly what you're looking for. I just named my grid, So of course I can add columns, definitions here. I can add and remove them here. That's pretty self-explanatory, right? You can add and remove columns here. The trick is then taking the children and assigning them to new locations within the grid. You do that by using the grid class. So if I want to set, let's see, what child do I have here? So here's one of my children. I'll just give this one a name. Oops. Child 1. Right now this is in row 0, column 0. Let's say I want to change this to row 2. I would call grid.setRow, and you pass in the object, which is now my child, or child 1, sorry. And then you give it the new value of 2. And what this will do is move this child to that new row. So in essence, we can manipulate the number of rows and all the position of the children in code behind. Does that answer the question?
Yes, I think so. Perfect. So okay. One other question that was on here was, is it possible to have a label inside of a grid row with auto, but constrain the number of lines for that label?
Can you repeat that?
Sure. The question was, is it possible to have a label inside of a grid row where the row is set to auto, but constrain the number of lines that the label actually generates? So make it 2 lines, for example.
Okay. So I guess in that sense, you would set the grid.row to be auto, and then you would set the height of the label to be explicit. So what I would do there is I'd say if I know 2 lines of text is about 50 dips or whatever, I would set the grid.rows. Is it not? Oh, by the way, this should have been column definitions earlier. That's why I had a hard time. So we'd set this row height to auto. Then we'd have a label inside that row, and I would just set the height here to whatever I need it to be to display 2 lines of text. Now, if the question is how do we measure the height of 2 lines of text, I think that's another question. I don't know if Xamarin.Forms has like the string measuring capabilities that, like, say, WinForms and WPF have. I haven't tried to do that myself. Where typically you can pass it a font size and a string, and then it'll measure the height of the text for you, so you can get the exact height that you would need. But I think I've done similar things like this before, and I've usually just given it a generous value that I assume will be good.
Yeah.
This row will then become 50. Anyway, does that answer?
Yeah, I think if you wanted to actually do the whole measure thing, you'd probably have to drop to each platform because each one's going to do that differently.
Mm-hmm.
I think that's it in terms of questions. Greg, thank you so much for the time, and we'll try to make sure to get this lecture online. So I have recorded it. We'll get it online ASAP, and I'll get Greg's slides from him, and we'll post those as well. Greg, is the code for the app that you showed available? Or is that something that's private?
Yeah, so the last 3 samples I showed, I can definitely share this. I don't know about the chart builder. The chart builder is pretty basic, though. I think the code's actually in the slides, pretty much. So
okay, perfect.
We can share the new samples I've created in the slides for sure.
Yeah, great, excellent. Well, thank you, everybody. Thank you so much. I hope everyone has a great day. Thank you for being an attendee of Xamarin University. Thanks, Greg.
Thank you.